I'm here to talk about event-driven architecture, software seams, and state machines. Oh my. So my name is Alix Klingenberg. I'm a software engineer at a company called Octopus Deploy. And the things that I'm really interested in, that I enjoy thinking about and talking about, are how we think about decisions that we're making when we're building our software, and the different things that people value differently that go into those decisions. So my hope for this talk today is that I can tell you a little bit about a system that I built, the constraints of that problem, and the decisions that I made around that. And you can kind of map that onto, problems that you're building, things that you're building, and how you understand these things as well. So the talk is hopefully more conceptual. It can apply across your favorite cloud provider. It can, apply across your favorite language and framework. But I will have some examples, specifically in .NET and a particular library that I used. But I think the concepts in it are really helpful. 25-minute talk. That's a pretty nifty talk. So we're going to be speedrunning this together, okay? So bear with me a little bit. We're going to go back and forth a bit. We're going to talk a bit about events. We're going to talk about boundaries. We're going to talk about events and boundaries together. And then I'm going to talk about how I thought about these things in AlfiePay, the system that I was building. Cool. So I was working at this New Zealand company called Aura, like Harry Potter, like my New Zealand accent. Cannot handle that. And Aura was a crime intelligence platform. And they had a bunch of customers who were fuel companies. And the fuel companies sort of said, look, people quite frequently drive off without paying for fuel. Maybe it's intentional, maybe it's not, don't care. Either way, we'd just like to give them the option to pay it back without having to come in to the store and do it face to face. And so Aura said, yep, we can build you something to do that. But we don't want to invest too much, right? Like, this isn't really our key business. We just want to see kind of prototype something, see if it'll work. So my boss kind of handed me a flow diagram of how he expected it to work. It's like, you have 3 months, have fun. And I call this the pinnacle of my career because they named it after my freaking dog, which I feel is like a software engineer badge of honor. And so it's a white label thing. You never actually see AlfiePay anywhere. But if you do go to alfiepay.com, it exists. So the fun thing about alfiepay.com was that this sort of process that my boss wanted me to build, this very clear flow chart of how things were going to work, he sort of said, we're not sure who our integration partners are going to be. We might run this in New Zealand. We might run this in Australia. Might run this in the UK, maybe the US for fun. We're not sure. We want it to be fairly configurable. We don't know when we're going to find that stuff out. Have fun. So AlfiePay was born. And we did actually hit the 3-month deadline, which I was super hyped about. Cool. So I've talked a little bit about the constraints of what I was trying to solve for when I was building this. And in particular, the first thing I sort of started to think about was, okay, AlfiePay has got to interact with a bunch of different external things. And so I wanted to start thinking about boundaries, right? So let's talk about that at a slightly more conceptual level. When we talk about boundaries, and I say this because I think conceptually what applies at kind of the architectural level, at the system level, some of the benefits and the concepts apply all the way down into the application that you're writing, the object-oriented code that you're writing, right? So essentially, we draw boundaries between things that we can kind of think of as a little unit. And that unit is something that can be understood by a single human, right, ideally. Not going to dive into like microservices sizing or design, because that's a whole ass talk. People have launched whole careers on it. I will say I really like the domain-driven approach to it. So I like to think of all of these little units as something that is kind of a coherent unit that a single human can understand, and it contains complexity. It gives you all the beautiful benefits that we know that service-oriented architecture or microservices gives us about being able to develop things in parallel, all of the beautiful stuff around being able to scale out, to sort of manage your infrastructure that way. And so we'd like to build boundaries into these things. But often when you are designing a system, you have a very beautiful view of what information is going to come into the system, what the system's interactions will be, But as software developers, we build these things over time. These things change. We want to add a feature. We want to move it around. And so these pristine architectural diagrams don't always survive just the long slog of building software, of living as a system. So what I really want to talk about today is thinking about the boundaries in our software, the information that crosses those boundaries, and how at the application level we can think about the kind of patterns that we're trying to create at that higher architectural level, and what inside the application is going to work with that. So yeah, boundaries, super important for you, important for your software. And I'm going to talk about events. So naturally, when there's a boundary, things need to cross it. Events are a very popular way of doing this. Look, I've put a bunch of names up there. To be honest, I had not even heard of, I think, event arc when I went to research it. My point is simply, this is something that cloud providers are very comfortable with. All of these things have different characteristics. We can understand a little bit more about them as we look at them. But I just wanted to say, this is a very common, nice pattern that people have. I also want to talk a little bit about what an event is, because I feel like we kind of smear the language of events across a couple of concepts. So when we're talking about an event, generally, it's information carried between systems, usually in the form of a message. And there are fancy tools that are more than a single message. I'm not going to get too deep into that. Let's just think of an event as information carried between systems, usually on something like a message bus, on an event queue. There are a lot of different tools that you can use depending on your requirements. But generally, it's about a state that has changed in one application that another application would like to know about. And that's the event, right? We kind of conflate the message and the event together, but that's okay. Not a problem. And as I mentioned, there are all these beautiful reasons to use them. But as a baby engineer, I wanted to learn about being on call. And so the company I was working at, PushPay, put me on call with an extremely senior SRE. And at that point, PushPay were not cloud native. We ran our own custom RabbitMQ server. And so I got to ride shotgun as we reconstructed message queues. And so I don't take things like message replay, like built-in retry, like poison letter queues. I don't take those things lightly. The cloud providers have got your back. They're amazing. And if you're not aware of the poison letter queue concept, the idea is you try to deliver a message or to process a message, fails a couple of times, you can sort of set it aside. Be like, you know what, never mind. We'll just pop this one over here and worry about it later. Obviously, you can do great stuff like, put alerting on these kind of things. And so you pretty much get all of this for free, right? So let's talk a little bit more about specifically what these events are going to look like. I have taken this from the incredible developer Martin Fowler, who did a great article and a great talk on this subject because I found it really instructive when I was coming to try and build this stuff. Event-driven is an ambiguous term, and it's useful to understand it sort of from that kind of boundaries level of understanding how events can be used to decouple services. But practically, the actual relationship between these services that are publishing and consuming events depends quite a lot on what type of event-driven you're talking about. So the first category is event notification. This is kind of like the simplest one. It's just a little bitty message that goes, hey, this thing happened. And then the next one, and you can see how we're sort of starting to build on that first idea, is the idea of event-carried state transfer. And so what we're thinking about there is that first message that said, hey, by the way, this thing happened. So using the AlfiePay example, the Aura monolith would go, ooh, this drive-off happened. And it would publish an event that AlfiePay could subscribe to go, ooh, I see a drive-off has happened. But when we start to talk about an event-carried state transfer, what we're saying is that event, that message that was sent, actually contains all of the information that is required to act on that event. And so we're going to talk about the implications that this is going to have for the interactions between your systems a little bit later. But these first two, they're what I want to talk about the most, the ones that I know the best. But additionally, there are examples like an event-sourced system, where conceptually, your system, at any given point, can be brought back to the current state by reprocessing the history of events, either from all time or from a snapshot. A typical example of this is an accounting ledger, right? Your bank account balance is the sum of all of your transactions and debits and so on. The final one is command query responsibility segregation, which sounds super duper fancy. What it's actually saying is we want to maintain two different kind of streams of information flow from our application. One is command, so that's doing something and likely mutating data over sort of an event stream, and the other is just read-only, basically querying. And I'm not going to talk about this one too much because, as I said, not my area of expertise. But this is what we're thinking about. So when you're saying event-driven, be careful because event-driven can mean a bunch of stuff. So I want to talk about events between boundaries. And I mentioned before, we know that boundaries theoretically have these magical properties of kind of allowing our allowing our systems and our services to operate somewhat independently. Events are a wonderful tool to communicate between the boundaries because it does what you can kind of think of as an inversion of dependency, much like we think of when we're looking at dependency injection within the scope of an application. And let's, once again, lift from the wonderful Michael Fowler, and steal his example, because I think it's really good. So say you have a user service, and your user service is responsible for maintaining and updating all the data about your user. User comes in, they change their address. Now, in a world where you aren't publishing an event, the rest of your system is maybe going to need to know. Let's say you send out physical invoices because you're old school. Your invoicing system is going to need to know about this address change so the invoicing system can send it to the right address. Is it the responsibility of the user system to tell the invoicing service about this? With the publishing of an event, you kind of abrogate the responsibility, right? The user system can go, hey guys, this happened. If you're interested, you can act on it. And so you can get wonderful things like fan out, right? So imagine that you also have a tax system. And maybe in some cases, someone has changed country, and you're going to need to know about that for very important tax reasons, right? So you can kind of see where you are putting the responsibility for subscribing to events, for consuming these events, with the services that should know about it, right? The ones that have the responsibility for that. And so in this way, you can have very clean boundaries. There are also sort of performance implications for it, which I want to talk a little bit about in a moment. Okay, so worked example, event notification. Remember, this is our number one version of event-driven with the least data possible, just a little heads up. So what I've done here is I have taken the JSON shape of the Azure event grid event because I think it's really interesting. So all of those top-level properties, those are just the the running of the Azure event grid stuff. The two properties in the data object, those are my two custom properties that are the two pieces of data that are going with my event notification. And in the case of AlfiePay, this was the format that we used. We would essentially receive one of these. We'd say, oh, look, debt created. Do I care about that organization? If I do, I'll go find out some more information. If I don't, throw it away. Goodbye. So this was event notification. And I think the thing to note here is that if we did decide we cared about that event, we still weren't in a position to act on it just yet, because we knew it had happened, but we didn't really know anything else. We can't sort of charge someone for something that we don't know anything about. So our other option is this event-carried state transfer. And again, same thing, all of the top-level properties, that's the standard Azure event grid stuff. Everything in data is theoretically what we would need to create this debt that someone could then come along and pay. So we've got information like, we know the country it happened in, we know the ID of the organization, we know the amount, we know their license plate if we want to look up their address. So this has enough information in it for AlfiePay to actually act on it. So this means that when you are consuming this event, at whatever point that you're consuming the event, you have enough information to not need to take a dependency on that other service, right? This is completely clean. The only dependency is on this event bus. The potential difficulty on that could be the timeliness of the information, right? So you may think that in your system, perhaps the thing that you are modeling is one where order is really important. Events are going to happen, updates are going to happen, and you need them to be in order. In that case, it might be a good case for the event notification pattern, because at that point you are always fetching the data fresh directly from the other service. However, you are not actually, in that case your consuming service has a dependency on the other service, which means that your data might be more timely, but the availability of these two services is more linked. So really, these are kind of the key parts, the key things of events, is that you get this inversion of dependency, you get to define what your service should care about within that service. Nothing else needs to know about what it cares about as long as it's publishing the events. But you also get these resiliency guarantees, but you have to think about how this kind of availability of your two systems works, how timely your data needs to be, and how important it is that one service can continue on with the other. Is it okay to have out-of-date data? Maybe it is, maybe it's not. These are things to think about. So let's talk about AlfiePay. This is Alfie. Events in AlfiePay were really fun. As I mentioned, it was quite a complex service, represented best by kind of the flow that a debt that was created and it could take. The debt was a kind of a central concern of the system because it was a very narrow system that only cared about this debt life cycle. We had really beautiful integrations. We integrated with the Aura monolith. We integrated with Stripe, who have an incredible developer experience. We integrated with Twilio, who are also here. Sorry, they did have a really lovely developer experience as well. We also integrated with the New Zealand government. So we were using, I think it was flat files over SFTP to get information from them. Additionally, we were sending physical letters. I hope none of you have received these, but if you have, one of the petrol stations may have said to you, hey, by the way. The really fun thing about physical letters was, this talk is kind of me trying to convince you that these concepts about boundaries and systems apply at all levels. I felt like I physically had a poison letter queue on my desk when I fucked up the null handling and addresses and got a bunch of undeliverable mail on my desk. It was like a physical event that I could hold. Anyway, the reason that I'm telling you about this is the event kind of driven paradigm is really powerful for operating on quite a granular level, right? So the events that we were receiving with Stripe, Twilio, from the Aura monolith, they were all operating on a single debt. But because we also had quite human integrated things like sending letters, like managing kind of the address flow, that big batch of files over SFTP, what we really needed to do was to make sure that we had a really good understanding of what was going to happen, what was the behavior of the system when we received one of these events to trigger a change, and what were kind of the performance characteristics of these things, right? Are we going to accidentally overwhelm Stripe if we process like a big batch of things? I mean, that's massive hubris for a Kiwi company, but theoretically, we needed to understand these things. And so this is where I started to think about this idea of a software scene. Again, in the very narrow application terms, you can think of it like maybe BDD, behavior-driven development, where you're thinking of like a slice, where it's a user story, right? So it's this cross-cutting concern across your different layers, but thinking about kind of that flow through the scenes, through the different layers, and understanding what sort of the performance constraints are across these different things. And so what we ended up coming up with was we wanted a way to, at the time that we were writing the application, that we were messing around with all the different stuff that it did. Maybe we were re-implementing it for another company or another country or something like that. We wanted a way to understand really clearly what the behavior related to an event was. And this is what I really loved. So we used this .NET library called Stateless, which is a state machine despite the name. And what's really cool about it is that it is a declarative state machine. So you can see here, essentially we create the state machine. I've called it AutoPay because Otto is my other dog and the AlfiePay code is proprietary and my ex-boss would kill me. So we've got this AlfiePay state machine. You can see it takes a debt. It knows about a debt. That is the central concern of the system of this process. And then we configure a bunch of stuff on the state machine. This is the part where we are declaring our business process, we are declaring our state machine, and we're saying, okay, we have the state, we start off with a new debt. And we have this active state. That's kind of a parent state. For an active debt, you can pay that at any time. Please, come on, that would be great, we love this. And so you can see on each of these states, we're saying, this is a substate of the debt state active. And so this gave us a really nice way to kind of control, I guess, interactions that were permitted at any point in this flow at a high level. Now, the traditional way that you might do this might be on the ingestion of the event, or it might be on the handling of the event, where you're writing an event handler, and you're going, okay, cool. So what are the potential things that could happen at this point? What am I going to allow? So the reason that we went with this was it centralized all of our understanding of what happened on the trigger, and we can tie those triggers there. That's an enum, it's just a list of potential triggers. We can tie those to the events that were coming in via our API, or were generated by us in the case where we were uploading a flat file or whatever. And we can see the behavior, right? You can see that on the debts we are, sending the reminder or whatever. We can include all of the behavior in there. And so tying all these things together, understanding at any point that we could call back, when we were going to look to the Aura system to get data from that, understanding what granularity that was going to be, how frequently that was going to be. And if we wanted to move stuff around, we knew what called what. So yeah, I really loved this pattern, really felt that building it helped me think about what the triggers for the events were, and by understanding what behavior was going to result from it, I tied my understanding of this interaction all the way back up through the different boundaries into the other systems, and what it was going to look like if one of them was down, or if we were still up while the other system was down. So yeah, this was kind of the thing that I found really helpful, was thinking at the application level how I wanted to manage the state change, and to do that in a centralized place in a way that was going to allow us to continue to maintain the dependencies that system had without sort of adding additional like a surprise dependency on other systems. I think my little buzzer went off, so I don't think I have time for questions today, sorry. But more than happy to chat about this. And thank you all for coming on the speed run through with me.